Alright, so here I'm trying to prove that lines L and M are parallel to each other, given that P and Q are parallel and that 1 and 2 are congruent to each other. So if I know that P and Q are parallel, then I know that these two angles have to be the same because they're corresponding angles in a set of parallel lines. So I'm going to start with that as my given, that P is parallel to Q because it's given to me, and that 1 is congruent to 3 because those are corresponding angles. And the corresponding angles postulate says that if I have parallel lines, I know that those corresponding angles are actually congruent to each other. Alright, so from there, I can see that 2 and 3 are alternate interior angles inside of lines L and M, but I don't know that those are parallel yet, so I don't know that those are actually congruent. However, I am told that angle 1 is congruent to angle 2. So now that I'm given that, I can really just make that jump. That's really what I want to show eventually, that these are alternate interior angles that are congruent, so these two lines have to be parallel because of that. So I'm going to use the substitution property here to show that angle 2 is also congruent to angle 3. Basically taking that angle 3 and substituting it in place of that. I also am flipping this around, which is the reflexive property, but I'm not going to state that there. Based on this, I actually know that lines L and M must be parallel. If I have alternate interior angles that are congruent, I can use the converse of that postulate to say that those lines have to be parallel. So the straightforward alternate interior angles postulate says that if we have parallel lines, then we have congruent alternate interior angles. This, the converse, is saying that if we have those congruent angles, we know that we also have those parallel lines. It just works backwards from the original direction of that conditional statement.